Hi, today we're going to look a bit deeper into the mesh analysis. And to do so, we're going to analyze the following schematic. As you can see, there are two voltage sources, which is a bit more complicated than we've seen before. And we want to calculate all the currents flowing in this schematic. Therefore, we have to identify the two loops. There's a loop on the left and a loop on the right. And I'm going to draw the currents right now. And I choose the currents to flow from the positive side of the voltage source to the negative side of the voltage source. So for the left one, I'm going to choose it to flow clockwise. For the right one, I'm going to choose it to flow counterclockwise. And I call them I1 and I2. It could be that if we calculate everything, that one of the two currents will be negative. That means that it turns out that the current doesn't flow this way, but it flows the other way around. But we don't know that yet, so we're just going to start and see what happens. From now on, we have to identify the positive and the negative side of each resistor. And we've seen in the previous video, whenever a current enters a passive component, so for example a resistor, that will be the positive side of the resistor. So in this case, this is the positive side and this will be the negative. It will be the positive and this will be the negative. For the other loop, the current enters R2 over here, so this will be the positive side and this will be the negative. And then here the current enters on top, so for the right loop, this will be the same as well. If I chose I2 to flow clockwise as well, the positive and the negative side for R3 will be different for both loops. Now we're going to apply the Kirchhoff voltage law to both the loops. I'm going to start with the left loop first. So I'll call it loop 1 since it's called I1. And I'm going to do that in green. So for loop 1, we apply Kirchhoff voltage law. We just start over here and we follow the current. So the voltage over R1, which is positive since we start at the positive side. So the voltage over R1, and we follow the current, and then we enter the positive side of R3, so plus R3. And then we continue, and then we enter the negative side of the voltage supply, so minus 4 volts equals 0. Now we're going to apply Ohm's law to calculate the voltages. Of course, there should be a V over there. And for R1, that's very easy since it's just the current times the resistance. So it's the I1, which is the only current flowing through. So it's I1 times the resistance, which in this case is 1 ohm, so times 1. Now we have to calculate the voltage over R3, and that's a bit more difficult because not only I1 flows through there, but I2 as well. So for R3 we get the resistance of R3, which is 2 ohms, times the sum of both currents. Since they both flow in the same direction, the current flowing through R3 is the sum of both the currents. So you get I1 plus I2. And just to make the algebra look a bit better, I'm going to get the 4 to the other side. So I'm going to add 4 to both sides of the equation, and I get a 4 on the right side. Okay, by now we want to get rid of the brackets. So you get that I1 plus 2 times I1 plus 2 times I2 equals 4. And then of course we can add the both I1s together, so you get 3 times I1 plus 2 times I2 equals 4. And I'm just going to leave it by that for now. And then we're going to look at the second loop, which I'll be doing in purple. So for loop 2, we're going to do basically the same. So we're going to apply Kirchhoff's law. So in here you see that the voltage over R2 plus the voltage over R3 minus the voltage supply, so minus 5, equals 0. Now we're going to do the same again, so we apply Ohm's law to this resistor, which is simple because only I2 flows through it. So you get that the resistance, so 3 times the current, which is I2, plus, well, we need the voltage over R3, and just as we've seen before, not only the I2 flows through it, but I1 as well, so we get that the total voltage is the resistance, which is 2 times I2 plus I1. And again I get the negative number to the other side, so I get equals 5. I'm going to correct that because it's not the prettiest 5 I've ever drawn. Okay, by now we're going to get rid of the brackets again, so you get 3 times I2 plus 2 times I2 plus 2 times I1 equals 5. Now we want to put it in the same order as the one on the right, so we start with I1. We've got 2 of them. 2 times I1 plus 3 plus 2 equals 5. 5 times I2 equals 5. And from now on, there are 2 ways to get to to calculate both the currents. You can do it with a calculator, one, for example, like I've got it in the video, or you can do it just by using algebra. And therefore I made 2 videos. So if you want to see how to do it just with algebra, just click on the schematic. And if you want to know how to do it with your calculator, just click on the calculator. Well, that was it for this video. So good luck with the ending, whichever you choose. And yeah, that was it.